astronomers have discovered a peculiar occurrence on Neptune. The remote world has lost almost all of the clouds that once decorated its apparent blue atmosphere. As a result, the world is now almost completely devoid of clouds. On Neptune, in contrast to the placid blue sky of Earth, the sky is never still and always bustling with activity. It features winds that may reach speeds of up to 2,000 kilometers per hour, which is equivalent to about 1,200 miles per hour. These tumultuous conditions whip up clouds of methane and other gases into an endless exhibition similar to a dance which can hardly be seen from Earth. But here's the startling part. In recent times, it appears as though all of Neptune's clouds had vanished, resulting in a significant change to the appearance of the faraway planet. When scientists uncovered the cause behind this alteration, things took an exciting new turn. They determined that the explanation was the 11-year solar cycle, the genesis of which is still a mystery to this day. So how exactly did scientists arrive at the conclusion that the Neptunian clouds had vanished, and why did this happen? How is it that the Sun, which is 4.4 billion kilometers away, is able to have such a significant impact on the atmosphere of Neptune? Finally, and maybe most significantly, what evidence do we have to support the theory that we have presented? Follow me to find out more. Hello and welcome to Zeey. Subscribe to our channel and ring the bell to receive our daily videos. The only spacecraft that has ever been to the planet Neptune was the Voyager 2 probe. This makes it the least studied planet in the solar system. During its historic flyby of Neptune in 1989, Voyager 2 revealed an atmosphere that was both spectacular and mysterious. The spacecraft found that the atmosphere of the planet is highly chaotic, with strong winds and interesting cloud forms to examine. In addition, the atmosphere of the ice giant is composed of multiple levels, the troposphere being the topmost one. It is in this layer that clouds are able to be observed, as here is where condensation occurs. The Great Dark Spot, which was found to be a gigantic storm system similar to Jupiter's Great Red Spot, was by far the most fascinating discovery. The Great Dark Spot on Neptune was discovered to be the same size as our planet by Voyager 2. However, when scientists using the Hubble Space Telescope focused their attention on Neptune in the 1990s, they found that the storm had mysteriously vanished. This was the first indication that the components of the Neptunian atmosphere were going through a profound change. The composition of the chemicals that make up Neptune's atmosphere was the most important aspect of the planet that Voyager 2 discovered. The analysis revealed that the primary components of these cloud structures are the gases hydrogen, helium, and methane. As a result of the methane in Neptune's upper atmosphere absorbing all of the red light from the Sun, the only light that is reflected from Neptune is blue, giving it its characteristic bluish tint. After examining Neptune for a period of 5 months, the Voyager 2 spacecraft delivered a wealth of data pertaining to the ice giant. However, since Voyager 2, no other spacecraft has been able to reach the planet due to its great distance from Earth, difficult engineering problems, and the huge expenditures involved. However, this did not mean that we eventually abandoned up on the distant parts of the planet. In point of fact, ever since the Voyager 2 mission, Neptune has been frequently studied using powerful space observatories such as the Hubble Space Telescope. These observations have enabled scientists to watch changes in Neptune's cloud patterns and even find new features on the planet. In addition, ground-based observatories that are outfitted with adaptive optics have generated high-resolution photographs of Neptune's atmosphere, which have revealed greater details of the cloud patterns that exist on the planet. However, the cloud cover above Neptune does not have a consistent appearance. It is always changing, and the clouds have almost completely dissipated over the course of so many years. Therefore, in order to keep a close eye on how effectively the clouds are dissipating, researchers investigated the temporal shifts in cloud cover that have occurred over the past 3 decades. They analyzed the infrared data that was gathered between the years 1994 and 2022 by the Hubble Space Telescope, the Keck Observatory, and the Lick Observatory. and the results of their investigation are very astonishing. Neptune is located 4.4 billion kilometers from the Sun, which means that it only receives 0.1% of the sunlight that we do here on Earth. When one considers this figure, it is only natural to conclude that the Sun cannot play a preeminent part in the dynamic processes that govern Neptune's atmosphere. However, when the researchers examined the photos of Neptune that had been taken by the various telescopes over the course of the previous 29 years, they found remarkably strong connections between the seasonal changes in Neptune's cloud cover and the solar cycle. This indicates that even though the planet is located at an incredible distance from the Sun, it is nevertheless subject to the gravitational pull of the star. Listed below are some photographs that were taken by the Hubble Space Telescope and the Keck Observatory between the years 2002 and 2020. These pictures are being used in this research project in a very specific way. After the beginning of the year 2020, there was a reduction in the amount of cloud activity, notably in the mid-latitudes. For instance, since the year 2019, researchers have only identified a single area of wispy white clouds moving around the south pole of the planet. Even now, after 4 years have passed, the level of the clouds has not returned to where it was before. Instead, for the first time in 30 years, nearly all of Neptune's cloud cover has been completely cleared away. Now the question that needs to be answered is, what part does the Sun play in all of this? It is crucial to have some knowledge of the solar cycle in order to comprehend this connection. The amount of energy that the Sun produces goes through cycles, just like how humans do. Just as we have times of high energy and times of extreme exhaustion, the Sun likewise goes through these cycles. There are bouts of increased activity that are characterized by a profusion of sunspots, periods of intense eruptions, and periods of relative calm. The term solar cycle refers to the regular variations in the amount of energy emitted by the Sun, which occur at regular intervals. It's almost like the Sun's way of adjusting how lively it is at any given moment. A solar cycle, which typically lasts somewhere around 11 years, is a reflection of the shifting behavior of the Sun. When the Sun is at its most active, which occurs during periods of solar turbulence, the solar system is inundated with UV radiation of a higher intensity. Solar cycles are a naturally occurring aspect of the way the Sun behaves and have an effect on space weather, particularly the effects they have on the magnetosphere of Earth and the communication systems that are based on it. In a recent study, researchers methodically studied the past 2.5 cycles of solar activity, which were highlighted by maxima in 2002 and 2015 and minima in 1996, 2007 and 2020, to observe their association with Neptune's cloud formations. The maxima of solar activity occurred in 2002 and 2015, and the minimum occurred in 1996, 2007, and 2020. This analysis uncovered a noteworthy pattern. The appearance of clouds on Neptune typically begins approximately 2 years following the beginning of severe UV radiation. In addition, a significant correlation was discovered between the cloud cover of Neptune and its albedo, which is a measurement of the amount of sunlight that a planet reflects. In 2002, the cloud cover and albedo of the globe reached their highest point. This was followed by a fall in 2007. After then, they continued their ascent and reached their highest point in 2015 before beginning their descent once more. The date coincides with the two most recent peaks in solar activity, which occurred in 2001 and 2015 respectively, demonstrating a definite association between the two occurrences as a result. The idea that the extreme ultraviolet light from the Sun sets off a complicated photochemical reaction that ultimately leads to the development of Neptune's clouds is one of the hypotheses that could help explain this occurrence. Nevertheless, this relation is somewhat complicated. For instance, an increase in the amount of ultraviolet radiation from the Sun would lead to an increase in the photolysis of methane gas, which would result in the generation of hydrocarbons and the hazes that they produce. On the other hand, an increase in UV radiation might also cause aerosols and hazes to darken, which would result in Neptune's total brightness being reduced. On the other hand, the only association that we have found to exist between solar activity, cloud cover, and the brightness of the planet is a positive one. This would imply that the Sun is not the only force at play, as it points to the possibility that the internal processes of Neptune are also having an effect on this behavior. The most recent observations are still being carried out, and researchers have also gotten additional data from the James Webb Space Telescope that is consistent with the results of the team. However, in order to arrive at a definitive conclusion, continuous observations of Neptune are necessary. What do you think, guys? Is there anything you like to say? Tell us in the comments and make sure you subscribe and ring the bell so you won't miss any updates.